So in the earlier table, that Cj minus Zj value has come as positive value, that is 2. That means we can improve the table further, because we have to do this iteration till we get 0 and all negative values in the Cj minus Zj values. So we'll write this. So here we'll write down these values: Cb, D, Xb. So Cj value 6, 4, 0, 0, 0. Then x1, x2, s1, s2, s3. So this is s3, 4, 0, 6. This is x2, x1, 40, 220, 290. So Zj value is equal to 2560. How we get this is 220 into 180 plus 280 into 6. This will give us 2560 x1 value. The row values which we have calculated in the same procedure, will get these values. So 0, 1, 2 by 3 minus 1 by 3, 0, 1, 0, minus 1 by 3, 2 by 3, 0, and this is 6, 4, 2 by 3. This is summation of this into this plus this into this plus this into this. Get these values: 8 by 3, 0. Here Cj minus Zj equal to 0, 0, minus 2 by 3, minus 8 by 3, and 0. So we have arrived at the optimum solution, because these values are showing all zeros and negative values. So that means we have reached the optimum solution and we don't need to proceed further, which indicates that we can produce 220 units of x2 and 280 units of x1. That would be the solution, which will give us maximum benefit or maximum profit of 2,560 rupees. Right here. So this indicates 220 units of x2 and 280 units of x1 can be produced to maximize profit, which is rupees 2560. So in brackets, this is 280 into 6 plus 220 into 4.